This week, we will start our study of statistics, and we're going to be looking at the topics of sampling, frequency distributions, and graphs today. We'll do some examples, and we'll look at a couple of the problems that students found challenging last semester. As usual, we're going to start with some definitions. What do we mean by statistics? You've probably heard that used many times. We mean a method of collecting, organizing, analyzing, interpreting data. We also use this, so that's the definition of how we look at the study of statistics. Statistics are also things that we gather when we gather data and we look at things like the average of the data, things like that. Those are also statistics. So it can mean a couple of different things, but when we're talking about the mathematical study, this is what we mean. And then we furthermore break it into two distinct categories. So we have descriptive statistics. That's when we collect data and we present it as a graph, or maybe we do some calculations and, like I said, present an average or some other way of describing the data. Those are all descriptive statistics. We also take those statistics and then we use them to make generalizations about the population from which we collected the data. And we call that inferential statistics because we're making an inference. We're trying to connect and say, this is what I think, why I think I came up with these numbers. So we break it up into these two categories. In this class, we're going to mostly be looking at descriptive statistics, but you need to know that the other type exists. And if you ever take, for example, an introduction to statistics class, then you'll start looking at how we can reach conclusions based on the statistics that we have gathered. A couple of other terms that are important is the population and the sample. The population is a larger group or the whole group that I'm interested in studying. So maybe I want to know what's the average age of students at Joyce University. So I could actually get that data from the population because the registrar or somebody at the university would have that information. So if I was able to look at the numbers from every single student, that would be the population. But if I was interested in getting maybe the opinion of every student at Joyce University on some particular topic, then I might not, hello, Rachel, then I might not want to use the whole population because I wouldn't want to have to somehow get in touch with all of those students. And maybe not everybody would even answer what my question is. So I would then look at instead a subset or a subgroup, and we call that the sample. So very important when we're in statistics, we always want to identify what's the population that I'm interested in, the whole group. And a lot of times when we're collecting data and then calculating statistics based on our data, we only get information from a sample, which is a subset or subgroup of the population. And the goal is that that sample is representative. So we want to make sure that we're not somehow picking a small group sample that doesn't represent the whole population. And so the best way to do that is by randomly selecting people from the population to be a part of our sample. That's not always possible, so we have lots of other ways that we do that. So first, let's start very simply, and sometimes students get confused on a problem like this one because it is very simple, so don't overthink it. So if I have a group of hotel owners and in some large city, and they want to conduct a survey among the citizens of the city to ask them what are their opinions about casino gambling. Okay, so the population they're interested in, that's the whole group, all of the citizens of the city, every single person who lives in the city. Now, again, would they be able to reach all of them and ask them how they feel about casino gambling? Probably not. So what we normally do is we somehow collect a sample. And the sample would be whatever people I am able to approach and ask about. So that would be the sample. Then we have another question. One of the hotel owners says, I know, for our sample, let's go to the biggest nightclubs in the city on Saturday night, and then we'll ask the people who are at the nightclubs to tell us their opinion. So does that sound like a representative sample? Like, does that sound like if you went to 6 nightclubs and you asked the people who were in the nightclubs on a Saturday night, hey, what do you think about gambling in a casino? They're probably not going to represent, right? Because you're not going to get people who don't like going out, people who maybe have a small family, they maybe aren't interested in that. So it wouldn't be a very representative. They say it's a terrible idea. Yeah, it wouldn't be representative at all. So it would be a sample, but it's probably going to give you an opinion that's different from if you were able to reach a more random group of people. So here's what we mean by a random sample. We somehow are able to select people in our sample completely randomly. So imagine if I could number everybody that lived in that city, randomly draw numbers out of a hat, however many I wanted. And then if your number gets drawn, you're going to be one of the people I talk to. In reality, we're not usually able to do that because some of the people may not be available, may not answer our call, and so forth. So the goal is always, can we get a sample as close to random? Okay, because we usually can't get a true, completely random sample. So here's another way. We are thinking about those hotel owners again. Okay, and so now this time we have some choices. What if we randomly survey people who live in oceanfront condominiums? Again, not very random, because what about the whole, if you imagine, the people that live in oceanfront condominiums would be a pretty small group, and they're not really going to represent the opinions of other people. The first 200 people whose names appear in a telephone directory. Well, now we're getting maybe a little more closer to random because we're not like just taking some little area of the city. So people might live in any different part of the city, but not everybody has an equal chance. If your last name starts with a Z, you're not going to be chosen, right? Now we're getting better. Part C. We randomly select neighborhoods of the city, and then we randomly select people within each of those neighborhoods. So that's getting a little bit better. This would be a much more random way to get the information. Questions about what we mean by a sample and what makes a sample good? Okay, the next thing that we're going to talk about is called a frequency distribution. So if I collect information, in this example, we're looking at the age of maximum growth for young men. Okay, so we have collected data from 35 boys. The one who was youngest at full growth was 10 years when he reached his maximum growth. And then the one who was oldest at maximum growth was 18 years old. So they range from 10 to 18, these boys reached their maximum growth. And so the raw data is all of this over here. These are all the ages that these 35 boys were when they reached their maximum growth. And so a lot of times we want all of that data. And if I'm a researcher, I'm probably going to look at all of that data. But if I want to present my results to the public or to whoever the interested parties are, then I want to start summarizing it somehow. And this is kind of the simplest way to summarize your data. And what you do is you just list all of the categories that the data fell in. So we had boys who were 10, 11, all the way up to 18 years old. And then I just count how many of them were 10, how many of them were 11. And if I was actually making this table here, the way that I would do it is I would use tally marks. So I would just come along here and I'm going to pretend that these aren't here. So I would say, okay, 12, there's a 12. Let's put a tally mark there. We've got a 14. we've got a 13. So I would just kind of keep track, and then at the end I would count the tally marks and put the numbers in here. And the nice thing about summarizing the data this way is that if I'm not the researcher and I just want to get a quick glance and I want to see what's the range of ages, well, they're ordered here. So I don't have to look through all of those data points and go, okay, what was the smallest number? What was the biggest number? I can just come over here and they're in order. So I see that the age range is 10 to 18. And then I can also look at, looks like from here to here is where we have most. So I could say that from 12 to 15 is the most common ages where boys reach their maximum growth. So it's just a nice summary that lets me look at the data without having to look at just this raw data. And it's a very simple way to summarize the data, and you don't necessarily have to do it by hand. There's lots of ways you can do it with technology. Here's another example, and this is statistics test scores for a class of 40 students, okay? And in this example, instead of counting like how many got each score, I'm going to group them into classes. And this is better when we have a big range like this. So in the previous example, the ages only went from 10 to 18. But here, let's see, it looks like we've got a low score in the 40s and a high score in the 90s. So if I had to list 47, 48, all the way up to 94, and then some of them I'm not even going to have any scores that were in that value. So sometimes it makes more sense to make classes or ranges of data that they fall into. And how do I pick what those groups are going to be? Like, how did I pick 40 to 49? It depends on the range of the data, and it depends on what the data is that I'm studying. So this is an example of test scores, and normally most grades go from 90 to 100 would be an A, 80 to 89 would be a B, and so forth. So that makes sense, a way to group them. When we do this, though, we want our groups to have the same range. So on the one hand, it might make sense to say, well, 40 to 49 is an F as well as 50 to 59, but I need to group them so that they all have the same number of data points in the range. And then I do the same thing as before, but so now when I start counting, so I've got an 82, so that's going to put a tick mark in this 80 to 89 range. And then I've got a 47, which is going to put a tick mark into the 40 to 49 range, and so forth. And so I end up with what we call a frequency distribution for grouped data. And we call these classes, and then we call the number of data items that fell into that class range the frequency. So classes and frequencies. And notice that the classes, or what we call the class width, are always the same. So I've got 10 values that fall in this range, 10 values in this range, and so forth. And we call that the class width. Questions about the frequency distribution?
So like when it's like a smaller uh like group of data, like you don't have to do like the class with.
So yeah, if my range was smaller, I might want to group them by 5, because normally we like to have somewhere between 6 and 10 classes. So that's another thing to take into consideration. Really good question. Yeah.
Okay.
We like to, I wouldn't want to, if I have 30 classes, well, I might as well just
Yeah.
stick with my original data, right? And if I only
Mhm.
have 2 or 3 classes, that doesn't really give me much information. So the magic number is usually somewhere between 6 and 10. And when you're doing this, when you're making one, usually the first thing is to kind of look at what's my highest value, what's my lowest value, and then subtract those. That way I know the range. Once I know the range, then I can say, well, I'd like to have maybe 8 classes. What happens if I divide that range by 8? What would the class width be? And then does that class width make sense for my data or not? If not, then let's adjust it.
Okay.
so that it does make more sense. So, you know, multiples of 5 and 10 are always pretty nice to have.
Yeah.
Okay. And then we can take this idea of this frequency distribution and we can make kind of a picture out of it. And we call it a histogram or a bar graph, depending on what our data is. If our data is something non-numerical, like maybe I was counting eye colors in a group of people, then we call it a bar graph. As soon as we have numeric data, then we call it a histogram. And what we do is along our horizontal axis, we show what the data values are. And then along the vertical axis, we show the frequency. So how many data items fell into that point. So thinking about our boys' age at maximum growth, we had one who was 10, we had one who was 17, one who was 18, and then the most of them were 14 with 9 of them in there. So this is a way of presenting it. And the nice thing about this is if the graph is done well, you can really see the trends very well. I think more clearly than you can when you're just looking at the table. But you also have the number, so you can, you know, look at, let's see, for 11 years old, how many were there? Okay, 2. So you don't lose any information by creating a graph out of it. Another way of graphing that, instead of doing the bars, we've kind of put these points on top. So at 10 years old, there was 1, at 11 years old, there were 2, and so forth. And then I just connect them. So these black lines and dots that are connected are called a frequency polygon. So we just create lines that connect all of those data points. And that's another way of really seeing, like, this really helps you to see where there are big jumps in the data and things like that. Questions about either of those before it looks like our next thing is going to be stem and leaf. Questions about the histogram or the frequency polygon?
No.
Yeah, they're all different ways of looking at that same data. And what a lot of times researchers will do is, because different graphs give you different not different information, but highlight different trends in the data. A lot of times in research, a researcher will give you multiple graphs. So if you're reading, you can see the different trends. And then here's another way that we sometimes summarize data. Usually data that's, you know, maybe 2 or 3 digits. The example that's in the slides here and that's in your book is only using data that has 2 digits, a tens digit and a ones digit. But it doesn't have to be. You can also use this, you know, with dollar values but the bottom line though is that you break all of your data points into a stem part and a leaf part. And the example we're going to look at, the stem is the tens digit, the leaf is the ones digit. So if I have a number like 41, the stem is 4, the leaf is 1. And so here's some 2-digit data. And so what we do, and I'll just kind of draw this out as we go. So I'm going to put my stems over here. I don't think we have any ones. I think 4 is the smallest, but I'll leave room in case I missed one. So these are my tens digits. And then I keep track of the data this way. So instead of like putting a tick mark for there's one, like here for there's one in the 80s, I put the ones there. So I put a 2 there because I had an 82. And then this number is 47. So over here in the leaves, I'm going to put a 7. And then 75, I go down to the stem of 7 and I put a leaf of 5. For 64, I go to 6 and then I put a 4. For 57, it's going to look like that. Now I've got another in the 80s, so I come down here and I actually write another 2. So this 2 represents one data item that was 82. This one represents the second one. Now I've got 63, so I go to the stem of 6 and I put a leaf of 3. and so forth. So for each of these numbers, I'm going to find the tens over here, and then I'm going to put the ones digit to the right. And the nice thing about these stem and leaf plots is, so here's the completed, okay. So I can see that there were 3 values that fell in the 40s and 6 values that fell in the 50s. And I also have all of the data. So I can see that there was a 57, a 54, a 56, another 57, and so forth. And most of the time, we take this one step further and we rewrite this and we put these in order. So instead of having 4, 7, 5, 3, I would write this as 3, 5, 7. It just makes it a little bit neater, and I like it better when they're ordered, but they're not always. So sometimes people leave it this way. Questions? Yeah.
On the textbook, so like yeah, the way I learned to do the stem and leaf when I did stats, like we do it in order, like after, like the
Yeah.
unit. But on
Yes.
the textbook, like the answers, like they're not in order. But like for like the tests and stuff, if like they ask that, should I do it in order? Like,
Oh, only if it asks for it.
okay,
So if it doesn't ask for it, you don't have to. Yeah.
okay.
Yeah. Oh, whoops, I forgot. I used the wrong thing there. It's not going to go away. Okay. Okay, so it sounds like you know how to do a stem and leaf. Yeah. And our book says the the stem is always 10, but I've seen them done with like um car prices, and so they round everything to the nearest like thousands, and then they would do like 35,000, 36,000. So the stem would be the 10,000s and the leaf would be the 1,000s. So yeah, it doesn't have to be tens and ones. Okay, oh, deceptions. Okay. So you probably studied this in statistics too. So people often used statistics and graphs and, presenting data in a way to make you believe what they want you to believe. So this is something that you want to kind of look out for when you're looking at a graph. So some things that help you see, is somebody trying to make me think something is true that really isn't true? So in the middle here, we have just the raw data. In 2015, the poverty rate was 13.5. In 2016, it was 12.7, and so forth. So we have these values from 2015 to 2019. And then, so both of our graphs, the graph on the left and the graph on the right, have the years in the horizontal axis. And they both have the poverty rates in the vertical axis. But look what this one did. This one went up by 0.5. So it goes from 10.5 to 13.5. So this looks like, wow, we were really, those 4 years, we were just really bringing down the poverty rate. But if you look at it over here, this is a little bit more representative. So here we've got 2 percentage points between. So now it looks pretty flat. And, from 10 to 13 is a little bit of a decline, but I don't think it's as much as this. This one's probably understating a little bit. I think it would be the most fair to do, 6, 7, 8, 9, and so forth. So bottom line is, when you look at a graph, make sure that you look at what's the graph telling me? Read the title. Look at the labels on your axes. What is being measured in each of the axes? And then look at the scale. Did they try to change the scale to make it look like the increase was bigger or smaller than it really was? That's just a summary of that. Yeah. Another way that people sometimes will manipulate data is with pictures. So if you look at what's going on here, we've got from 1980 to 2020, the number of square feet in an average US single family home. And they kind of did a couple things that are manipulative here. So they went from 1980 to 1990, and then they skipped forward 30 years here. So that's kind of not really fair. It makes the jump look even bigger. Whereas if they had gone 2000, 2010, 2020, that would have been a little bit less manipulative. And then they added this shadow of the home and they put the sun at a pretty high angle. So it makes it look even bigger, doesn't it? So they really kind of wanted to emphasize that, oh, the size of a US single family home has really grown, which it has, but not, at a level of this makes it look like it's grown by 4 times in 3 time periods, where it's really grown by, what is that, about 700 in 40 years. So a little bit different than what they're trying to make it look like. Other questions?
I feel like I don't have any questions about like statistics. Um, but I do just have like some questions about geometry.
Okay, let's do that. Let's see. I am going to share. Oh, do you have a specific questions like from the homework or just general
Yeah.
questions?
Um, well, I have it from like the textbook, like the problems that she suggested to like do for studying for the test.
Mm-hmm.
It's
Yeah,
in exercise set 10.2 and it's number 9.
it's exercise. Say that again.
10.2 and it's number 9. It's like a
Exercise.
weird wheel
Okay.
looking thing.
Okay, let me find that. I don't know why this is okay. Just trying to get this to open up. Oh, I didn't share my screen yet. Okay. No, not that one. Okay, you can
Yeah.
see our course now. Okay. And so it was in, no. Oh, which module was it in?
It's the geometry part 1.
Geometry part 1. And was it one of the questions from the book?
Yeah, yeah, it was in the textbook. It was like one of the
Oh,
suggested problems to do.
okay. Let me pull up that textbook then.
Mhm.
Let's see. So which chapter?
Um, it was chapter 10, 10.2, and then it's like the exercise set 10.2.
Okay. So I'm gonna go here and then go backwards. Okay. So it was one of these problems?
Yeah, yeah, number
Yeah.
9.
Number 9. Okay. So let's get rid of this. There we go. Okay. So most of these types of problems are going to rely on parallel lines. So remember when we have like parallel lines with a transversal, then all of
Mhm.
these angles are going to be congruent, right?
Yeah.
And then all of these angles. And then we have our vertical angles, which are always congruent. And then we have our triangle where the angles add up to 180, right? And we also have supplementary angles, right? So these two angles add up to what?
One or 90.
Those are also 180, remember?
Oh, I was supplementary. Oh my, I get confused. The complementary and
Okay, so
supplementary.
supplementary, I always think C for complementary, S for
Mm-hmm.
supplementary, alphabetical order. This
Mm-hmm.
one's smaller, this one's bigger.
That's a good way to think of it.
That's how I taught myself to remember that. And then
Mm-hmm.
this one, these make a line, right? So
Yeah.
these are
Oh
what we
yeah, no,
call a
line's
straight angle.
180.
Line's
Uh-huh.
180, and then this one is 90.
Mm-hmm.
So I know all of these things. So these are the things that are going to help me. So when I come over here, I look at, do you see any vertical angles?
Isn't it like the one and the 55?
Yes. So this one's 55. What else?
Um, 120 and then 6.
Mm-hmm. Good. And then what about any of these that make a straight angle?
120 and 7. So that would
Yes.
be 60.
Mm-hmm.
And then wouldn't that be the same thing for 8? Because they're like
That's right,
straight
because they're
angles.
vertical angles. Yeah. Mm-hmm. And then we know L and M are parallel.
Mm-hmm.
So what angles does that help us with?
Isn't that with the
And sometimes this one kind
uh-huh.
of will throw people off because
Mm-hmm.
that's like
Yeah,
an
that's what's
extra
throwing me
line in
off.
there.
Yeah.
But if you just look at this is parallel to this, and then we have this transversal. So which other angles are going to be 55 degrees?
Is it mm, 9?
That's
Or
right. And
okay. Because they're all like the same, they're inferior angles, right?
yep, so
Would
9
4 be
and
it
what
too
else?
or no? Or 10?
10, because they're vertical, right?
Mm-hmm.
Yeah, so 55. Now, how can I get 4?
Um, wouldn't you have to find what 2 is? Or wait, you could do 55, like it's a supplementary angle, right?
What
Oh wait,
is
4 is the triangle. So you
Yes,
could just
that's
do
right. So now
180.
we've got this triangle here. Yes. So we've got 55,
Mm-hmm. Or
60,
60.
and angle
And
4, and they have to be 180.
mm-hmm. So it'd be 65 for 4.
Yes. So 4 is 65. So what else do I know now?
2.
Yes, 2 is also 65. And now I've got a couple of ways that I can get 3 and 5. Like this has to be 180, right? This guy here has to be
Mm-hmm.
180. So I could add these two and subtract. That's one way to get angle 3. But also using these parallel lines again and now focusing on this transversal. Okay. Angle 5 is congruent to what other angle that's being cut here?
Um, wait, what does congruent mean again?
Oh, the same measure.
Oh, would it be 3?
Well, yes, but also,
Oh yeah,
uh, so we have 60 here and here.
that seems like I don't know why in my head that was so like complicated for me. Like,
Oh, there's a lot
wait,
of steps. So I
yeah,
just I just kind of look, for things that are easy. To me,
mhm,
this is one of the easiest ones. So I look
yeah,
kind of for those first. Vertical angles are also easy. So I look for
mhm,
vertical angles. Then I start looking for parallels and transversals. And sometimes you have to go back a little bit, back and forth a little bit. But yeah.
yeah,
And this one, there's a lot. You kind of have to keep putting
yeah.
things together. Yeah,
Okay, that helps. Thank you.
good. Yeah.
Can we try that number 10 real quick, just so I can like see if I
Yes.
got it
Yeah,
down?
let's do it again. So what would you start with there?
Probably like the 135 and 8, because that's 135.
Yes, uh-huh.
And then wouldn't 10, or would 10 be the same as 8? Or no?
No, not
10 would be the same
necessarily.
as 7.
Mm,
No,
7 is going to be the same as, so
same as
7
6.
and 6 are the same as 3 and 4 because they're with this transversal.
Mm,
Yeah,
yeah.
okay.
So
But what are
7 and
7
6
and
would
6?
be 45.
Yeah, uh-huh.
So that means 4 or 3 and 5, these are on the same line or no?
So we have this situation.
Uh-huh.
So we'll just forget about this line for a second, and we have 3, 4, 6, 7.
Mm. Okay,
Yeah,
that it's all those lines, like they confuse
that
me.
extra line definitely will throw you off. So kind of try
Mhm.
to ignore that for a minute.
Yeah. Those at 3 and 4 would be 45.
Yes. Uh-huh.
And then we could find the uh oh, one would be 65, right? Or are those like
Yeah. Yeah.
still
Vertical
okay.
angle with this one. Yeah. Good. Hmm.
And then you can find the supplementary with 5, right? If you do 180 minus 65.
It has to be this whole thing. So you have to, right? It's
Oh,
4, 5, and this one. So there's actually
so
3 angles.
it would be
S-
70,
Yes.
and then 270 as well.
Correct. Yes.
And then 9 would be 45.
Mm, what do these 3 have to add up to?
Oh,
This is, sorry,
180.
this was
Wait,
70. Yeah, not 9. It looks like 90. It's 70. So this one has to be,
45. 35. Oh, so it's not like an equal triangle. It's like a little off.
yeah, so angle 5, angle 6, and 9 have to add up to 180. So 70 plus 45 plus angle 9 has to be 180.
So there, it would be 45, 65.
Hmm. And then angle 10,
Oh, that's like the same. It's 9, right?
that's right. Yep. Also 65. Huh?
Okay. I think I just need more practice with these and then I'll be able to like get it down.
Yeah, it does take practice.
Mm-hmm.
Mhm. So I think the hardest one, and it was the hardest for me to kind of get down to, was when they throw that second line in. If they leave out a
Yeah.
line, I'm okay. I can see, if they just do this, I can easily see which ones are the congruent angles. But as soon as they put in another line, I'm like, wait a minute, where did that? So kind of try to imagine it without that line,
Simplify it.
or even redraw it, without the line and see what
Yeah.
you
I was thinking that. Like redrawing it
have.
probably
Hmm.
would help.
Yeah. Now some of the things are going to be a little different, right? Because you don't have these 1, 2, and 3 anymore, but that's okay. Well, you still have 3, but this is 1 plus 2, right?
Yeah.
But as long as you draw that, you can get a lot more, and then you can plug them back into here and see what you have.
Mhm. do you see number 6? It's like right
Yeah.
down. If you go down a little bit,
Yeah.
I
Just
was
get
just looking
this.
at that. I was like, I feel like I have an idea of how to do it, but like I don't know.
Okay, so what does the little box there mean?
That's 90.
That's 90. Okay. So what else do we know?
Um, well, can't I find the triangle through the 105? Or no, wait, I would have to do.
Oh, I thought you meant this triangle.
So is 90 part of that triangle?
Well, if this is 90 and this is a straight angle, then this has to
Oh,
be
that
90
makes.
also. Yeah.
Mhm.
So
So the.
anytime I do a
Mhm.
90, the other side is 90 also.
Okay.
So
And
then
then so
one
one would
is,
be 40,
yep,
and that would make 3 as well.
yep.
So then if I do 80 minus 45, that's 135 for 5, right?
Oh,
Oh, I could do that too
so
for the
that's
3
these
and the
two
2
add
because
up to
they're,
180.
yeah.
Yeah, so these are 135. But remember the triangle, it's three. So
Mhm.
this one, and this one are 180.
So 180 minus, oh, wait, that is, that's 35 then, not 135.
Yes, yes. And also kind of use most of these are drawn to scale, right?
Mhm.
So remember, this is 90. So anything bigger than that has to be more than 90, and anything
Yeah,
smaller than that has to be less than 90. So you can kind of use that.
sure.
So if I got 135 here, I'd be like, that doesn't seem right. That's less,
Yeah,
it should be less than 90.
that's true.
So that helps me too, to think about like
Mhm.
what makes sense. All right, what else?
Let me look one. What about for number 14? It's like finding the length, or like, yeah, it's finding the length for number 14 of the triangle, like the missing length.
Oh, okay. So I'm gonna label these. So so, okay. So if you look at the triangle that's labeled ABE, that's the bigger triangle. ABE. And then this smaller triangle CDE. Well, they both have a right angle here, angle A and
Yeah.
angle D. And then they share this angle. So that means that this third angle here, these have to be the same angle. So that means the triangles are similar. All three angles are the same.
Mhm.
And whenever triangles are similar, then their sides have a constant ratio. So the ratio of this side here, AB, to this side here, CD,
Mhm.
is going to be the same as the ratio of BE to CE. And then AE to DE. So all of those sides have that same ratio,
Mhm.
whatever it is. Well, we know what it is here because AB is 5 and CD is 4. So all of these sides have this ratio of 5 to 4. And the
Mhm.
one that we're trying to figure out is this one here. And we don't know AE, but we know that it's X plus 5, yeah?
Yeah.
And then what do we know about DE?
It's 5.
It's 5. Mhm. And then to solve this, what we're going to do is anytime we have a ratio equal to another ratio, we call that a proportion. And to
Mhm.
solve it, we can cross multiply. So we multiply this numerator times this denominator. That gives us, I'm going to write it over here, 25. And it has to be equal to this product. So 4 times X plus 5.
Okay. We could do minus. Oh, and then it would be the ratio of. So I would
So,
get a negative.
so let's see. So you have
Oh
25.
wait, no, I wouldn't get a negative. Sorry. I would get
So
five.
did you distribute this? So you get 4x
Yes,
plus
plus
20. Okay.
20.
So you get
And then
5
subtract 20.
equals,
Uh-huh.
mhm.
And then divide by 5, or would you divide by 4?
We need to divide by 4
Oh, to get x
so that we
alone.
just, yeah. So that's 1 and 1/4 or 1.25.
Mhm. So would that be the missing link would be that as a decimal.
Yes. So
Okay.
x is 1.25.
Hmm. That's a strange one. I didn't see that on my homework, but I was like, I'm trying to just like do everything I can before the
Good.
exam, just because I don't like geometry. I'm like scared.
Oh, yeah, I mean, if you can do the problems that are in the homework and that are the practice problems, you should be fine.
Yeah.
Yeah.
There's number 37. It's like the tree problem with like the shadow.
Oh,
I
yeah.
did that yesterday at the tutoring center, but I felt I forgot to write it down. I want to write it
Okay.
down so I can like
Yeah.
do it over and over again.
So 37.
Yeah.
Why is this not? Oh, it's on the next page. No wonder it won't scroll down. Oh, here we go. Yes, the
Oh,
tree. Okay. So this is basically the same thing, but now they threw a tree in there. But other than that,
mhm.
it's the same thing. So like if we redraw a similar thing over, I'm going to redraw it like this. So this is the tree. There's our person. This is 5 feet. This is 6 feet, and this is 80 feet. And then if we label it again, and what we want, what's the distance I'm trying to find?
The height of the tree.
Yeah, which is this AB, right?
Hmm.
So I want AB. And so if I first look at these two sides in the big triangle and the little triangle, that's going to be AB to DC, right? So
Yeah.
that's
So that
kind
would be DC is 5, would be x over 5.
of, And now what sides do I have in those two triangles?
We have the height of the person and the shadow.
Yes, so these two sides correspond to one another.
Hmm.
And then this side corresponds to this side, yeah. And then this side corresponds to this side. So I have to think about in my numerator, I'm going to have my bigger triangle. So my numerator, I'm going to put aside from AB. Ugh, can't read that. Oops. So in my numerator, I want to have a side from ABE, the big triangle. And in my denominator, I want to have a side from CDE. And I want them to be sides that are opposite the angles that are congruent. So you see AB and CD are both opposite this angle here.
Hmm.
That's angle E. And then this angle here is congruent to this angle. And what are the sides that are opposite them? In the bigger triangle, this angle is opposite this side, AE. What about in the smaller triangle?
Is
What's
it
the,
DC or AE or DE. Mm,
You know what? Before we do this problem, let's just look at one that's a little bit simpler so that I can show you kind of how to find those, because I think that's
okay.
the part that's, okay, so I'm just gonna draw, and they don't have to be 90 degree, but in this case they are. So here's A, B, C, and then here's another triangle, D, E, F, okay? And these are both 90 degrees.
Mhm.
And then these angles are congruent and these angles are congruent. Okay. And so that means since all three angles are congruent, that means the triangles are similar. And then
Mhm.
the sides that are opposite congruent angles have the same ratio. So if I take a side from this triangle that's
Mhm.
opposite angle C and compare it to one from this one opposite angle F, then it's going to be the same ratio as the sides that are opposite, say, angle A. So what I'm going to do is I'm going to compare, in my ratios, I'm going to compare a side from triangle ABC is going to go in my numerator, and a side from angle DEF is going to go in my denominator. And then first I'm going to look at sides opposite two congruent angles. So let's look at angles A and D are congruent, right?
Yeah.
So angles A and D. So in triangle ABC, opposite angle A, what I mean by opposite is if I go from that angle and go to the side, that's going to be side BC.
Mhm.
In this triangle, it's angle D that's congruent to that. So I'm going to go from here and I get this side EF.
Yeah.
Okay. What's another pair of angles that are congruent in these two triangles? We looked at A and D. What other angles are congruent?
Like, would it be EF and BC? Oh wait, that's what we just
Angles.
wrote.
Yeah, what
Um.
other angles are congruent? So we have angles A and D are congruent.
Oh, C and F.
C and F are congruent. So looking at angles C and F, which side is opposite angle C in this triangle?
Like BA
Yeah.
or AB.
Yeah, it doesn't matter. They're the same.
Okay.
And what about opposite angle F?
ED.
Mhm. Okay. And then what's left are angles B and E.
Mhm.
And in this
Multiply that
triangle,
is
what's opposite
AC.
angle AC? And then what about here? Opposite angle E,
DF.
DF. So let's just say that I know this is 3 and this is 4 and this is 2.
Mhm.
Okay. So which of these can I use to solve this? Let's see, I have BC and EF. That one looks really promising, doesn't it?
Mhm.
So the ratio of BC to EF is what?
4/2.
4/2. Do I have BA and ED?
CANE. Well, we have BA, but not ED.
Yes. So if I call EDX, what would
Mhm.
that ratio be?
Um, 3/x or would it be
Yes.
x/3? It doesn't matter.
It does matter. So however I wrote
Okay.
it here is how I need to
Uh-huh.
write it. So BA is 3
Uh-huh.
and X is ED. So now I know these are equal and I can solve this for X.
And you would cross multiply it.
Yep.
So it would be 4x equals 6.
Mm-hmm.
And then would you divide by 2
So
to
whatever I
simplify it or
multiply by,
no?
I have to multiply by whatever or divide by whatever I'm multiplying here.
Oh, so the 6/4.
Yep. Mhm.
That makes more sense. I think it's just like the tree. Like just be confused. Like
So for the tree, just redraw the tree. Now we're going to redraw this guy. And here's the triangle that has the tree in it.
mhm.
And I'll call that one ABC. And then do I know any of these distances?
We know the 86-foot shadow, right?
Yep.
That's BC.
Yep. Or no,
Oh, A.
that's AC, yeah.
Uh-huh.
Do you see
AC.
that?
Yes. And just like what's that dotted line supposed to mean?
They're just making a triangle.
Oh.
That's the sun. The sun makes the same angle.
And
Yeah. We don't
then we
actually
don't
use
have
this, but we
oh.
could find it using right triangles. And then the little person, we'll call that
Mhm.
one DEF. And what distances do I know?
We know the like
Do I know
we know D
EF?
to F or
Yeah, D to F is,
6,
what else?
and then D to E is 5, and then we
That's
don't
right.
know E to F, right?
Yeah, but we don't need it because what are we trying to find? We're trying to find AB.
The height. Okay, yeah.
And we have all of these ratios set up here. So we have BA to ED we can use, right?
B S D E
And we know that's going to be, we don't know BA, but that's okay. That's what we want. And ED is
5.
5. And then we also know which of these, so we use this one. Which of these two do we know?
E S.
We don't know EF, that's this one.
No, D S.
Oh, DF, yes. So
Uh-huh.
we know AC to DF, yeah?
Mm-hmm.
Whoops. Did not mean to do that. Hold on. I messed this all up. Okay. Undo that guy. Okay, so AC to DF. And what's AC?
86.
Uh-huh. And DF?
86.
Yep.
Then you cross
So,
multiply,
yep.
and then you get 6x equals 430, and then divide by 6, and you get 7.16, or like if we round it up, 7.17,
Yep.
and that's the height of the tree.
Mm-hmm. No, that can't be right.
Yeah. Oh no, it's
Oh, it's
71. Yes,
71.7.
yes, yes.
How did I know that was, how did I know that was wrong? I knew that was wrong because I'm like, wait a minute.
Yeah,
Look at
no.
the, yeah, look at the picture. Yeah. We just had our decimal point in the wrong place. Yeah. Okay.
Yes, okay, that makes so much more sense. Thank you. That like helped me a lot.
Yeah, no
I feel like
problem.
I can actually
Um,
do this now.
yeah, and like I have to really stop and draw the pictures and think about these two, especially when they start like flipping the orientations of triangles.
Mhm.
And so if you really
Yeah,
focus in on which angles are congruent and then which sides are proportional,
yeah.
then you're just plugging in.
Uh-huh. Yeah. Thank you.
Yes, thank you so much for coming again.
Yeah, thank you.
Yeah,
Okay.
you betcha. All right, you have a great week.
You too. Bye bye.
Bye-bye.